Do it. All right, so chapter 10, finding the area of a quad or a triangle. So what is a quad?
Four-sided figure.
Four sides, and they're all connected, and nothing weird, right? This is okay. This is not okay, right? That doesn't work. Okay, cool. Just want to make sure. All right, so we've got a bunch of different quads. We've got parallelograms, which are just quads with parallel sides. Not all sides are parallel, that would be impossible, but opposite sides are parallel. We've got another type of parallelogram, which is a rectangle. You need to know this chart, guys. Rectangle, which is a parallelogram, except all its angles are now 90 degrees, okay? Sides don't have to be equal. Turns out opposite sides will be, right? This is kind of how real life works. And then we have a more specific type of rectangle, which is really just a square. It has all parallel sides, just like a parallelogram, which is why it is a parallelogram. And it has all angles 90 degrees, but what's cool about a square is that all the sides are also equal. And you know this stuff, right? So we've got all those. And then the family tree gets weird. I'm going to go over here to where it doesn't. This thing called the trapezoid.
It's like your cousins.
Yeah.
It is. I used that story in the other class, I guess. I thought you'd heard about that. But anyway, trapezoid. All that is that one pair of opposite sides are parallel. One pair of opposite sides are parallel. See how these two are not parallel? They're going to intersect. This guy and this guy is. I could also draw a trapezoid like this.
What does it mean when you draw? You do that and then you put a line in front of it. What does that mean?
That the sides are equal.
Oh.
Like this.
Oh.
It's a square. Yeah, it's okay. Good question.
Which is the rhombus?
So you're asking about the weird family, huh? All right, so trapezoid is all off on its own. It's not a parallelogram because parallelogram has all sides parallel, right? Opposite sides. This just has one pair of opposite sides. Over here, we've got a kite. And kites look like this. Turn on their sides, right? I'm drawing the thing in the middle. You don't have to, just to help you remember that a kite is a kite. The thing you fly, that thing, right? So a kite is going to have equal angles here. These angles are not going to be equal, necessarily. They're different measures, but these two are going to be equal. And these two are going to be equal in length. These two are going to be equal in length. So it's kind of weird. Okay? And then the square of a kite, right, the special kind of kite is a rhombus. And the rule for rhombus is that all of the angles are going to be the same, okay? No, I don't want to do rhombus is weird, guys. All the sides have to be equal. That's it.
And then the angles are greater than 90 degrees.
Some are,
And then some are.
right? The angles can be different. Rhombus is weird. People think that a square is just, or a rhombus is just a square turned on its side. No, because these can be this, right?
Yeah, it's just a square.
Are these sides parallel? Yeah, sort of. So it's sort of like a parallelogram, but not really, because it's strange, right? It's kind of like a trapezoid. It's just bizarre. So it's kind of connected to the square, but sort of only maybe, right? They're like really distant cousins, or an aunt that you really hate, right? She doesn't understand you, you don't understand her, and she brings you weird gifts at Christmas that you'd never want for yourself, right? Because she doesn't know who you are, right? You're a freshman in high school, and she's bringing you like squirt gun toys from like the dollar section at Target, right?
Beth.
Yeah. So.
Yeah.
Cool. So we're live. So this is a thing, sort of. The way I teach it is just keep them separate. You know, keep one family over here, that family over there. Don't mix them. That's just weird. We talked about that. So keep them separate, and you're fine. If you say a rhombus is a kite, is a quad, fine by me, right? You don't have to go through both sides of the tree. It's okay. You understand what a rhombus is, right? All sides are equal. So that's your family tree. So if something is a square, it's also a rectangle, a parallelogram, and a quadrilateral. If something is a kite, it's also a quad. If something is a trapezoid, it's also a quad. If something is a rhombus, it's also a kite, also a quad, right? We go up the tree. If it's a rectangle, is it a square? Not necessarily, right? We know it's a rectangle, then it's definitely a parallelogram, definitely a quad, right? So you can't go this way in labeling things. You can only go up. So if I give you a parallelogram, I say...
That's so inspiring.
You can only go up. Can't go down from here. You've hit rock bottom. So, parallelogram. if it's a parallelogram and I don't tell you anything else about it other than it's a parallelogram, right? Opposite sides are parallel. The only thing you know about it other than it's a parallelogram is that it's also a quad. It's got 4 sides. So let's talk about something that doesn't have 4 sides.
Triangle.
It's gone. The special thing. This is the triangle family tree. Triangles. All you really need to know is that this guy's in it. That's it. I mean, there's isosceles, there's right triangles, there's all that stuff, right? I don't care. Okay, we're talking about geometry, we're talking about area. There's really no difference here. So a triangle's a triangle's a triangle. It's something with 3 sides. Again, 3 butt heads. That is not a triangle. Okay, it has to be connected. So cool. And all of these things we talked about are the bigger thing, polygons, right? They're things with sides, which means circles and things with curves don't count. So this would not be a polygon. Okay. I have thought of that joke. But I've got limits, okay? I know when to stop. So, area of quads and triangles. All quads and all triangles can be made into rectangles, which is helpful because we know the formula for rectangle is what? Area equals the base times the height. Cool. So we've got a rectangle, and we've got our base, and our height, and whatever they are is what the area is, right? This is 3, and that's 2. It's 3 times 2, which is 6 units squared, because we're talking about area, right? We're talking about the number of little rectangles, 1 by 1 rectangles, and I should say squares, because they are squares, that fit inside this thing, okay? So how many squares fit in it? Well, 6 squared units, right? Cool. That's nice. When we're talking about a triangle, any kind of triangle, doesn't have to be right, doesn't have to be anything, you can turn it into a sort of rectangle. First, we're going to talk about parallelograms. It's this thing. Right? This is also a parallelogram, but people typically draw them like that. So these are parallel, and these are parallel, which means it's a parallelogram. It also has this special formula, area base times height, because this is your height, right? Height has to be straight up and down. You don't measure your height by doing this, right? You measure your height by standing up as tall as you can. That way people think you're actually 5'8" when you're really 5'7" and 3/4. Okay? So actually, I think I'm 5'8" and 3/4. I'll never tell. All right, this thing is your height. This is your base. So really all this is a triangle over here. And we can move that triangle over here. So I'm going to take this triangle, and I'm going to move them over here. Oh, look. It's a rectangle. Base times height. That's why it's the same formula. Blew your mind. Or at least I would if this wasn't a review session. Triangle. Also has a height. Straight up and down. Makes a little triangle. What happens when we take this little triangle and move them over here? Can you do that? No, you can't. Doesn't work that way. What you really do is you take this triangle and you make 2 of them. So you copy it and you flip it upside down and put it on top. We got a parallelogram. And we know the formula for parallelogram is what? Base times height. So this was our base of our triangle, right? Nothing changed with that. Nothing changed with our height, so it's still base times height. Except we want to know about half of the parallelogram. So the whole parallelogram is this, right? We want to know about half of it, so we got to take that and multiply it by half. Half base times height. So if my base was 3 and my height was 2, we'd have 3 times 2 is 6, divided by half, or multiplied by a half, right, is 3 units squared. Do we understand this concept? Cool, moving on. So that's kind of neat. Triangles are really just half of a quad, right? Which is weird because triangles have 3 sides. You'd think it'd be half of like something with 6 sides, but it's not. Let's talk about the trapezoid. This is the hardest formula to memorize, but I'm going to talk about it right now. A trapezoid. Again, we have a height, and this time we have 2 bases. We've got a big base, call it base 1, and a smaller base, call it base 2. The formula here, if you do the weird thing, this is the formula. Area equals what? The average of the bases, right? We've got 2 things, so you got to divide it by 2 after you add them together. Base 1 plus base 2 divided by 2. Times what?
Height.
The height. Have you ever seen this before?
Yeah.
Yep.
Good. It's base 1 plus base 2, whatever the lengths are, divided by 2. Why? Because we're trying to find the average of the bases. We're trying to find what would a base be if we had it here. It's halfway in between, so it's the average of the bases. No.
Just kidding.
I mean, kind of. It does go through a
If
center
you were a
point, but
circle.
center is relative. Yeah, if you were a circle, right, then my arms would be radii. I don't know where we're going with this. All right, so yes, this is the formula. Plug it in, memorize this, or turn it into a rectangle. I don't have time for that, okay?
Ain't nobody got
This is the thing. I don't memorize that formula. I just turn it into a rectangle. You do you, okay? So let's talk the area of a kite. Again, you can divide it into triangles, and you can move those triangles over here, and we basically just got a rectangle, right? Cool, except what happened was that we had this length here, which I'm going to color in blue. Let's get rid of all this. We're going to call that D1, distance 1, and we're going to call this distance 2. When you move the triangles, okay, so this is what we originally have. Let's make a copy of it. When you move the triangles, so you do this, and you move them over here, and you get your rectangle. Notice that D2, our red line, is the same thing. So we've got base, which is just D2, okay? But this guy over here, maybe I should change them. I should. No, I won't. That's for circles. What are you doing? R2? Oh, no, it was. You're right. So we're going to call this D2, this blue one. So I can do my joke that I invented on the fly the other day. D2 gets cut in half.